So let me start the introduction part of the algorithm subject. From now onwards, please be careful. It doesn't matter how much you are comfortable with the algorithm subject as of now. That is the reason I am starting with the basics of algorithm. You cannot say afterwards, I don't know basics, that is the reason I am not good in algorithm. You cannot say like that. Now itself I am clarifying. I am starting from very basic point, very small point I am starting. I am thinking that, right, most of the people may not know basics of algorithm, right? With that I am starting. I know that many people knows this, but still I have to take care about all the people. That is the reason I am starting from basics, right? Please listen properly. Even though you know I have to take care about all the people, right? Just listen. Any one new point also there, you take care. Most of the things maybe you know, one new point also there, you take care. In computer science, if you are really comfortable with algorithm subject, you can do anything, right? So please be careful. Everything there. Don't study this subject for the purpose of marks. Study this subject so that you will learn everything, right? I am starting. Everyone is capable. The only thing is some people will believe, some people are not believing. This is the only difference. So I am starting now. See this one, algorithm. Very basic point onwards I am starting. See the basic point. Definition of algorithm. See this one, many people know. Only for namesake I am writing. Anything new you take care. Definition. It is a combination of sequence of finite steps it is a combination of sequence of finite steps to solve a problem. It is a combination of sequence of finite steps to solve a problem. So it is the algorithm definition, right? Many people know this definition, right? No one will ask you definition also, but it is better to say clearly. That is the reason I am starting from basic. Definition I written. It is a combination of sequence of finite steps to solve a problem, right? Let's give one example also. I am giving one example. See the example, right? Any I think I have to give small example. Just I am giving this one. See this one. Addition of two numbers. Right? So this is the algorithm name. Addition of two numbers. I have two, right? I want to add two numbers. So you can write complicated algorithm also. Now itself I don't want to write complicated algorithm. Just I want to explain algorithm definition. Right? I am starting this one. Addition of two numbers. Addition of two numbers. Can you say first step of addition of two numbers? You want to add two numbers. Can you say first step? First step is going to be take two numbers. Take two numbers. Right? Take two numbers. That is the first step. Some people are asking. Right? Take two numbers, it's okay. Right? So what are those? Let us assume that. Take two numbers. Assume that those are A and B. Take two numbers. Those may be A and B. Right? Next one. So the second step. Add A and B and store in C. Add A and B, store in C. That is the second step. 3. Return C or print C. Print C or return C. Whatever you want, you can do. Return C or print C. Right? Afterwards, end of the algorithm. So, I want to write an algorithm for adding two numbers. Right? That is the goal. See, I want to make sure that everyone will get my lecture. That is the reason I am starting from basics onwards. Definition onwards I started. Right? So I written the definition. I am giving one example also without thinking anything negatively. Right? Please listen properly. So definition I written. Right? This is the example. Right? So what is the first step? Take two numbers. Those are assumed that A and B. Second step, add A and B, store in C. Third one, print C. Right? These are the three steps. Now see the definition and talk. See the definition. See the definition now. It is a combination of. Algorithm is nothing but it is a combination of course, these three required. Now can you help me one small line now? Out of these three things, can I remove second line? Then from where C will come? Can I remove first line? From where AB came? Next one, can I remove the third line? If I remove the third line, how will you print C? Right? So can you help me now? Algorithm definition, it is a combination of, what is the meaning? All compulsory. All compulsory. Combination means all compulsory. It is a combination of, sequence of. And one more thing I want to ask you. Combination okay means all three compulsory, that is okay. Can I swap 1, 2? Can I swap the first statement, second statement? Can I swap it? No, I cannot swap. If you swap, first one is add A and B, store in C from where AB came. So I cannot swap. Can I swap the second statement and third statement? No, I cannot swap. So what I want to say, algorithm is nothing but these are all compulsory, and one more thing, right? Sequence also mostly important. Combination required, all compulsory, mostly sequence also important, and one more. Can you say how many statements are there? 3 statements are there, right? Finite statements is one. Finite steps. How many statements are there? 3 steps are there. Finite. So can you help me now? Algorithm should contain finite steps. In this algorithm, how many steps are there? 3 steps are there. So algorithm should contain finite steps. And one more thing, finite steps, everything okay. At the end, it should solve our problem. All compulsory, order also important, and finite steps. Finally, it should solve our problem. Yes, it is solving problem. What is my goal in this problem? Printing C. Right? This is the meaning. All compulsory, most probably sequence also important, and finite number of steps should be there. Some people are asking, finite steps not there, infinite steps there. What is the problem? If infinite steps are there, it will take infinite time. Finite steps are there, it will take finite time mostly. Infinite steps are there, it will take infinite time. So some students are asking me, what is the meaning of infinite time? What is the meaning? Right? So if the algorithm contains infinite steps, it will take infinite time. Some people are asking, sir, what is the meaning of it will take infinite time? It will take infinite time. The meaning is going to be, it will take infinite time. The meaning is going to be, I written the algorithm, right? So if I write the algorithm, I have to see the output of that algorithm. I written the algorithm, right? That algorithm output I didn't see, right? After I go, my children are seeing. Means it is taken a long time. If I write the algorithm, I have to see the output immediately. I written the algorithm, right? My next generation is seeing the output. So that is the meaning of infinite time. Every algorithm should contain finite steps. The reason is, mostly it will take finite time. If infinite steps are there, it may take infinite time. Please be careful. So every algorithm should take finite steps only. Finite steps are there, mostly finite time. Infinite steps are there, it will take infinite time. Right? Please be careful. All compulsory, mostly order is important, and finite step. At the end, it should solve your problem. Suppose it is not solving your problem, then what is the purpose of writing? So this is the algorithm definition. Definition I given, one example also I given. Right? Please carefully follow from now onwards. So definition fine, right. It is a combination of sequence of finite steps to solve a problem. Right? See this one. Sometimes maybe order changing possible, but mostly sequence is important. All compulsory. And one more thing I want to ask you. By removing 2 also, this algorithm is working. Then why you written 2? By removing, suppose by removing 1 also, this algorithm is working. Then why you written 1? So mostly all are compulsory. If I felt that it is not necessary, then why I will write? Why I will waste time also, space also? Everything compulsory, mostly order is important, and finite steps should be there, right? So it is a combination of sequence of finite steps to solve a problem. One example I given, right? Many people know. It is better to explain clearly. I took this. Now next one. See the next one now. See the next one. Properties of algorithm. Next one is going to be properties of algorithm. What is the meaning? I will explain this also. Everything is important. It is, try to remember this one. It is your subject. Algorithm computer science means, right? It is your subject. You please learn everything. You please learn everything of this particular subject. From definition onwards until high class, right? You learn everything. Please practice this subject as much as possible, so that you will settle down in your life, right, very easily. Do you know this particular line or not? See this one. For other branch people, getting job may be very difficult. For CSE people, getting is very easy. The reason is going to be almost like 5 lakh software companies are there. If you go to the Bangalore, every house is almost software company. If you go to the Bangalore, every house is software company. As a CSE person, getting job is very simple, very easy also. Other branch people, it is very difficult. But CSE people, getting job is very easy. But the question here is going to be, getting job is very easy. But the question is going to be, how much salary you are expecting? Suppose you are so good in an algorithm subject, more salary they will give. If you are not good in algorithm subject at all, still they will give job. But salary is going to be 1,000 rupees per month. 3,000 rupees per month. Some companies will ask you, will you pay some amount so that we will give the job? Some people will ask you, we will give 3,000 rupees per month. So try to remember, as a computer science student, getting job is very simple. But if you are comfortable in this subject, right, you will get the high package jobs. If you are not comfortable, then also you will get job, but very less package jobs you will get. So that is the reason I know importance of this subject. That is from basics onwards I am covering. Definition I said. Now see the next line. Properties of algorithm. Now some people are asking, what is the meaning of this? See, what is the meaning of this? Carefully listen. What is the meaning? Supposition that, right? I written something. Make sure that everyone listen. Supposition that I written something. I am thinking that it is a algorithm. I written something. I am thinking that it is an algorithm. As a computer science student, if it is algorithm, right, what property this thing should be satisfied? I have something, I want to say it is an algorithm. As a CSE person, how will you verify it is an algorithm or not? Can you help me now? What is the first property? If it is algorithm, it should satisfy. First step. What is the first property? Right? Many properties may be there. I want to say important points. See this one. If anyone say it is algorithm, first important point should be, if it is a algorithm, it should terminate after some time. It cannot go to infinite loop. If it is an algorithm, it should terminate after some time. That is the first step. Some people are asking, sir, algorithm already contain finite step, guaranteed it will take finite time. Then what is the meaning of it should stop, right, within finite time and all? Try to remember, if algorithm contain infinite steps, it will take infinite time. If algorithm contain finite steps, mostly it will take finite time only, right? But sometime it may take infinite time also. If algorithm contain finite steps, mostly it will take finite time, but sometimes it will take infinite time also. Some people are asking how, right? If you want, you can see now. Like this. See this one? Like this one. While 1 printf high. While 1 print high. See this one? This algorithm contain only 2 steps. While 1 print high. This algorithm contain only 2 steps, but it will take infinite time. 2 steps only there. While 1 print high, it will go to infinite loop. Now I think the correct time to ask you, if algorithm contain infinite steps, it will take infinite time. If algorithm contain finite step, it may take finite time. Sometimes it will go to infinite loop also. That is the reason. See, that is the example. Now can you help, if anyone say it is algorithm, as a CSE person, can you say first property, what you will verify? What is the first property? If it is algorithm, what is the answer? It should terminate. It should terminate after finite time. It should terminate after finite time. That is the first step. If it is algorithm, it should terminate after finite time. Right? See the second step. Second point. If anyone say it is algorithm, first property what you have to verify is it terminating or not? After finite time, is it terminating or not? Right? If it is algorithm, it should terminate after finite time. That is the first property. And one more interesting thing. Right? If it is algorithm, it should terminate after finite time, it's okay. One more important point is after terminating, output should come. Suppose algorithm terminated, means algorithm stopped. Finally, no output came. Then what is the purpose? You completed, suppose assume that, right, from now onwards you practiced the entire GATE examination, right, you prepared a lot. finally GATE exam is over, no result came, then what is the purpose of that kind of preparation? If you prepare properly, you will definitely get the nice rank. Suppose you prepared day and night, finally no rank came, then what is the use of that kind of preparation? So prepare in such a way that you will crack nice rank. Need not be nice GATE rank, right? At least, right, based on that particular preparation, you should get some job, some nice job should come. There should be some output. Need not be GATE rank. There should be something because of you done the really great work. Maybe GATE rank, maybe some other PSU job, some other software job, something should come, some output should be there. If it is an algorithm, what is the one more fundamental property? Right? It should produce output. It should produce at least one output, sometimes maybe many. Suppose if I prepare for the GATE examination, at the end of the GATE exam, right, I may get GATE rank. I may get some other job also. Many more may come, that is also okay. GATE rank will come, that is okay. Right? Many more will come, but one thing, at least something should come. Minimum one job should be there. If anyone say it is algorithm, what is the first property? It should stop after finite time. What is the second property? It should, right, it should produce at least one output. Many will come, I don't have any problem, but at least one thing should be there. It should produce at least one output. Many may be there, at least one output. Next one, three, right? It may take input, it may not. There is not necessary. See, main program don't take any input. And one more thing, in the previous one, see this one, there is no input. You may take inside, that is okay, but starting you may not take. Right? You may take input, you may not. Input you may take, you may not take, but output should be at least one output. At least one input is wrong. You may take, you may not take. Main function may not take input, and this function also not taking any input. So that is the reason. Let me write now. It should take 0 or more inputs. It should take 0 or more inputs. That is the third point. Fourth point. It should take 0 or more inputs. See the fourth one. It should be deterministic. It should be deterministic. Some people are asking, what is the meaning of algorithm is deterministic? What is the meaning? Right? Algorithm and deterministic meaning is, to this algorithm, if you give A as input, right, output came B. If I give A, output B came. If it is an algorithm, for this algorithm I given A as input, then I got output as B. Suppose assume that after 1 hour, if I give A, again B should come. After 1 day, if I give A, again B should come. Suppose assume that if I give A now, output B came. After 1 hour, if I give A, C came. Means input is same, but outputs are different is coming. That is going to be non-deterministic algorithm. What is the meaning of non-deterministic algorithm? Same thing, two different behavior. Sometimes for the A, B coming, sometimes for the A, C coming, sometimes for the A, D coming. Right? This is going to be non-determinism. What is the meaning of determinism? A given B. After 1 day, you give A, B. After 30 days, you give A, B. That is the meaning of determinism. Algorithm should be deterministic. Everyone want deterministic algorithms only. No one want non-deterministic algorithm. Your parents also expecting from you deterministic behavior. If you keep on behaving differently, right, in your family, no one will like you. Right? 1 day looking so good, another day so bad, another day medium. So no one like this. Every day similar kind of behavior. Right? So algorithm should be deterministic. Some people are asking some non-deterministic algorithms also there. Right? Then why don't you consider that one? Right? Non-deterministic algorithm practically not possible. They are theoretically present, practically not there. Deterministic algorithms are practically there. Right? Please be careful. Algorithm should be deterministic. It should terminate after finite time. It should produce at least one output. It should take 0 or more inputs. It should be deterministic. Many points are there. Many points are there. I want to say major things, I written. Suppose from today onwards, if anyone asks you, I have something, I want to say it is algorithm. What properties it has to satisfy? Minimum these should be satisfied. Minimum these will be satisfied. Please be careful. Algorithm definition I said. I given one example. Next one, to say algorithm, what qualities it should satisfy? Minimum these qualities should be satisfied. Right? I'm thinking you are fine now. Right? Fine. Many more may be there. If you open the book, many things you will find out. If I say more, you may forget it. Best thing is necessary statements. Let me write. I written properties of algorithm. Right? After properties of algorithm, see the next one. Steps needed or steps required to design algorithm. Steps required to design algorithm. What is the meaning of this line? Right? So, supposition that I have a problem. Okay, carefully listen this point also. What are the previous two things you done? Algorithm definition, one example. Next one. What are the properties of algorithm? Right? Means what is the meaning of properties of algorithm? I have something to say it is an algorithm. Right? Properties should be satisfied. Next one. Some people are asking, sir, I have a problem. Right? To that problem, I want to design algorithm. To that problem, I want to write algorithm. Right? What steps I have to follow? So, there are some steps are there. If you follow blindly those steps, right, you will get the algorithm. Some people are asking, what is the meaning of you will get algorithm, right? So, if you follow I will explain few steps now. If you follow those steps, you will get the algorithm. The meaning is, after getting that one, if you check the properties, automatically it will satisfy. Right? What are the steps I have to follow so that I will get algorithm for the given problem? I am explaining now. Right? This also many people know. It is better to explain once I am explaining. See, steps required to design algorithm. See the first step. I have a problem. I want to write algorithm for that problem. What are the steps I have to follow? See the first step. First step is going to be problem definition. This is the first step. If you want to write algorithm for any problem, first step is going to be problem definition. What is the meaning? What is the meaning of problem definition? Right? You should understand clearly what the problem is. That means, right, for the given problem, what will be the input? If I give input A, what will be the output? If I give input B, what will be the output? So, for every input, you should know what is the output. What is the meaning of problem definition? Problem definition is nothing but, right, to this particular algorithm, if I give input A, what will be the output? Input B, what will be the output? For every input, right, you should know what is the output. Supposition that for this problem, right, input if I give A, right, supposition that I don't know what is the output, that means you don't know problem clearly. So, if you want to write algorithm for any problem, first step is going to be, you should know problem clearly, means for every input, what will be the output, you should know. Suppose if you don't know, for a particular input, what is the output, indication that problem you are not clear. If you are clear with the problem, input to output mapping is done. Right? So, let me say this one, problem definition is over. See this one, problem definition is over, indication that input A, B is the output, input C, D is the output, and so on. Input Y, output is Z, like that. So, input to output mapping is properly done. Suppose for a particular input, I don't know what the output, indication that problem having, right, problem don't have clarity. Now, again I am repeating now. If you want to write algorithm for any problem, first step, know problem clearly. What is the meaning? Problem definition. What is the meaning? For every input, what is the output I am able to map. If you are unable to map, problem not clear. Right? Please be comfortable. That is the first step. Next one, after knowing the problem clearly, see this one, after knowing the problem clearly, carefully listen. Second step. After knowing the problem clearly, because of you clearly know what is the problem and all, right? Next one is going to be design algorithm. Or propose designing technique. Second step is going to be, after problem clear, second step is going to be design algorithm or propose designing technique or select designing technique, right, like that. That is the second step. Right? First step is going to be know the problem clearly. Second step is going to be, right, select the designing technique or design the algorithm or propose the designing technique, something like that. I written one line, design algorithm. What is the meaning? right? The meaning is going to be, carefully listen this one. This is very, very important. This thing many people don't know. That is the reason these many problems are coming. Right? See the second step. After knowing the problem clearly, second step is going to be design algorithm. The meaning of that one is going to be, for a given problem, if you want to write the algorithm, you no need to write everything from your side. Algorithm subject already having some algorithm, right? Out of those the existing algorithm to your problem, which is more suitable, please select. That is the meaning of design algorithm. That is the meaning of, right, selecting designing technique. That is the meaning of, right? So select the designing technique and all. Please be careful. Second step is going to be, because the problem clear, right? Algorithm subject already having some algorithm. Algorithm subject having already some algorithm, right? So for your problem, which is more suitable algorithm, please select it. That is called as, right, design algorithm. Right? Algorithm subject having already algorithm to your problem, which is more suitable, please select it. Right? Those are, see this one, those are, first one, see this one, those are. One of the designing technique is going to be, right, divide and conquer. That is one of the designing technique. To your problem, a problem is clear, after got to know problem is clear, algorithm subject having so many designing technique, to your problem, which is more suitable designing technique, please select it. Select designing technique or design algorithm, both will be same. Select designing technique, these many designing technique, divide and conquer, next one is greedy technique, next one is the dynamic programming, next one is going to be, after dynamic, next one is going to be branch and bound, next one backtracking. So like that, so many designing techniques are there, right? To your problem, in the existing all algorithm, which is more suitable, please select. If you select the more suitable one, right, within less time, you are able to write the algorithm for your problem. Many designing techniques are there. Some people, see, if you don't follow this, what is the answer? For every problem, from the scratch you have to write. Right? But if you use this technique, what is the meaning of using this technique? Already our elders created so many algorithms to your problem, which is more suitable, in the existing algorithm, please select. If you do that, two advantages. What is the one advantage? First of all, you will save your time. What is the one more advantage? You are respecting the elders. The elders are done, see, there are so many PhDs are happened in algorithm subject. Right? If so many PhDs are happened, lot of work is done. If lot of work is done, right, I think you can use that. When you can use the available things, why are you writing from scratch? Already printf code is there inside the C library. Why are you writing the printf code from your side? Already scanf code is there inside the C library. Why are you writing the scanf code from your side? Why don't you utilize it? Already in algorithm subject, our elders are created so many algorithms, right? So to your problem, which algorithm is more suitable, please select. If you select the more suitable one, very less work is there to do from your side, right? So you can select any one. If you select that one, which is not more suitable, you have to do more work. Now I think this is the major line. Many people don't know this line. So if I ask one of the student to this problem, write the algorithm, he is writing from scratch. What is the best idea? Instead of writing from scratch, what is the best idea is, can I solve this problem using greedy technique? Can I solve the problem using dynamic programming? Can I solve the problem using divide and conquer? You can think like that. Instead of thinking infinite ways, what is the best idea? Existing things try to map. Some people are asking, sir, how to map the existing things? How I know what are available, what are not available, how I know? That's what you study in algorithm subject. In algorithm subject, what you study is, right, what are the existing algorithms already? To your problem, existing things, how to use. That's what the meaning of studying algorithm subject. If you want to write everything from scratch, then why you want to study the subject? Some people are thinking that whether I will study or not, I have to do from scratch. If you want to do everything from scratch, then why are you studying? What is the requirement of listening these many lectures? What is the requirement of studying this much big book? Right? Algorithm book is normally contain 2000 pages, 1000 pages, 1500 pages like that. Then what is the meaning of studying that kind of book? If you study that book, you got to know what algorithms are there, what algorithms are not available. Right? Next one, to your problem, which is more suitable, which is not more suitable, you can easily find out. Now I think I am repeating once again. I have a problem. I want to write algorithm for that problem. First step, know problem clearly. Because of you know the problem clearly, right? In the existing algorithm, which is more suitable, select. Suppose that to my problem, greedy technique is more suitable, assume. So I selected. It is something like I have a real estate business. I want to create a website to that real estate business. I have a real estate business. I want to create a website to that real estate business. Right? One idea is going to be do everything from scratch. One more idea. For real estate business purpose, so many, right? Website templates are available. Please take one thing, whichever you like. So many, right? Real estate business purpose, so many templates are available. Please select one of the template, right? Please change according to your requirement. So one more thing I want to ask you. You want website for the real estate business, right? You have to select the template of real estate business. If you select some other business, if you select some other area, then also you can create a website for your business. The only thing is, because of wrong selection is done, right? To update that one to your requirement, more time it will take. So many templates are there to your particular business which is more suitable. Select that template so that, right, you can get your required website within few seconds or within few minutes. If you take the wrong one, it may take more time because so many things you have to change it. Selecting the correct template, which is nothing but, right, in the available designing technique, select one thing, that is called designing algorithm. So this is a very crucial step. Here if you take the wrong decision, it will take more time. Here if you take the best decision, it will take less time. Some people are asking, sir, how can I select the best one? Some people are asking, right? How can you select the best one is either you should have experience in this area or you should be smart. Two things, every time two things will come. If you are smart, within less time you can learn. Suppose that you are not smart, you have a lot of experience, that is also okay. Mostly in this area, experienced people will be there or smart people will be there. Right? When you practice algorithm subject again and again many times, you will also become smart. Right? If anyone thinking that I am teaching very well and all, the major reason for this one is I taught to so many students. So many people I taught. Approximately, I can easily say that 50,000 students I taught until now. That maybe there is this much fluently I am able to talk. Right? Without saying anything, I am able to talk. The reason is going to be, right, many people I taught. When you do many times, right, even though you are not comfortable starting, when you do many times, it will become normal. Right? Fine. I am saying that this is the critical area. If you have more experience, you can handle this area. If you are smart, then also okay. But one thing is true, right? Designing algorithm means I don't do everything from scratch. In the existing designing technique, one thing I will select. Suppose, assume that to my problem, greedy technique is the best one, right? Assume that I selected. So second step is completed. Know the problem clearly. Yes, based on that, in the designing technique, one technique you select, that is also okay. Now see the third step. If anyone don't want to use the second step, existing things if you don't want to use, that is also okay. If you want to write from scratch, unnecessarily you are wasting your time. You are not respecting elders also. Right? Please be careful. I think second step also over. Now see the answer. Second step is over means, right, 90% to your problem you have algorithm. Second step is over means, right, 90% to your problem you have algorithm. So after second step, designing algorithm is completed. Indication that second step is over, indication that for your problem 90% of algorithm is available. Problem clear? Based on that, in the available designing techniques, one thing you selected means 90% of the algorithm to your problem is available. Right? Remaining 10%, how to make? All right. Let's see this one. Second step is over because of algorithm is available. Can you draw the flow chart? Right? Third step is going to be draw flow chart. Right? Third step is going to be draw flow chart. Algorithm is available. You can draw the flow chart. Everyone, a flow chart is nothing but representing the same algorithm in the form of a diagrams. In the form of diagrams, please represent. Right? So second step is over. Third step is going to be draw in the form of flow chart. Isn't that flow chart also available? Can you help me now? If flow chart is available for the given flow chart, right? If I give input A, right? So I think so many boxes will be there. Condition true, go left. Condition false, go right. Like that, so many things are there. Give A, whichever path it is going, follow. Lastly, output will come. Whenever flowchart is there, we can verify A is given, what the output and all. Just verify, right? Fourth step is going to be testing or verification. Because the flowchart is there, you can verify A is given, B coming or not, yes. C is given, D is coming or not, yes. Like that, continue. Y given, Z is coming or not, no. Like that, keep tick mark. So testing is going on. All possible inputs, whatever you are given at the time of problem definition, right? All will be verified here. Supposing that Y given, Z should come, but it is not coming. So this tester will inform to the designer, algorithm designer. Your algorithm, everything is okay except one of the point. So you will do little bit modification. And the flowchart also little bit modification. Again testing, it will continue until all will be right. Right? So flowchart is modified, testing is done again. It will continue until all will be right. That indication that all are tick mark, indication that, right? Your problem, exact algorithm is available. When you done the second step, what is the meaning? Right? Because of, if you do right selection, 90% of algorithm available. Supposition that if you done the wrong selection, 10% of algorithm only available. If you do medium selection, 50% only over. Anything you can take, right? Anything you can take. If you take the best possible matching, right? Less work you have to do. If you take the worst matching, more work you have to do. Suppose if the best matching I done, 90% is possible. Afterwards, draw flowchart testing. Remaining 10%, 1 or 2 lines you can add, 1 or 2 lines you can delete. Supposition that testing is successfully completed. What is the meaning? Testing successfully completed, indication that, right? For your problem, now you have algorithm. To your problem, you have algorithm. This story, whatever I said to you, this story will repeat less time if you do right selection. Right? This story will repeat more time if you do wrong selection. Right? Fine. Testing is over means to your problem, algorithm is available. Now we'll see the next one. Because of to your problem, now algorithm is available. Right? See this one, algorithm is available, flowchart, everything is there. Now fifth step is going to be because of everything is okay. Just to do coding, which is also called implementation. Because of everything right? Now you can go for implementation. You can implement. Implementation means coding using some better programming language, which is more suitable to this particular one. Right? In this, when you saw the flowchart, you will get to know which is more suitable in the existing programming languages to implement this particular algorithm or flowchart. Right? Which is the best programming language? Call all developers or call the project manager, because project manager knows many languages. He is having lot of experience. By seeing this flowchart, you can easily say which language is more preferable. Supposition that, right? Project manager said that, right? To this particular algorithm to implement, best language is assume that Java, right? In Java they will implement. Right? They will call all the project managers who are working in that company, they will ask, right? This is the algorithm, this is the flowchart which we have to implement. Which programming language is preferable? Please let us know. Suppose someone said that Java is better, right? They will go for Java. Using some programming language, please implement. Some people are asking, why should I code? Right? If you don't code, for the input A, what is the output? You have to do manually. If you code it, one time just do coding. Just afterwards, by giving A run, output will come. By giving D run, output will come. Right? That is the advantage with the computer system. In the computer system language, you write so that it will give answer whenever you will ask. If you don't write the program, every time you have to do manually by yourself. Right? Using some programming language just to do implementation. That is also coding. Right? Next one, see the sixth point. So coding, everything is completed. Now, right, your program is ready to run. Coding, everything is completed. Now your program is ready to run. Now can you help me now? If your program is ready to run, right? When I say run, can you help me now? Before running, where is the program? In hard disk. But when I say run, now program will goes to main memory. From there, program is running by CPU. When I say run, my program will go from hard disk to main memory. From there, CPU is running the program. Now, when our program is running, right, program will be there in the main memory and running by CPU. Now, the question is going to be, while running, how much CPU time it will take? How much main memory space it will take? Right? This is known as analyzing the algorithm. Right? Last, sixth point is going to be analysis. Sixth point is going to be analysis, right? While running, program will take how much time, how much space is known as analysis. Analyzing the program or analyzing the algorithm, right? That is going to be sixth step. Supposing that whenever this step is going on, right? So analysis is over. If it is a better one, comparing with another one, people will use this only, right? So comparing this one and other one is better, people will use other one. So they have to analyze before going to use, right? So suppose it's the best one, it is taking the less resources, it's the best one. This is the sixth step, analysis. Can you say what is the first step? Know the problem clearly, problem definition. Next, based on that, in the available designing technique 1, right, whichever is more suitable, select. Because the algorithm is available, draw flowchart. Because the flowchart is there, by giving different inputs to verify, right? By giving different inputs, please verify. Right? When I verify, right, I got to know something wrong, inform to the designer, he will change again, flowchart also will change again, continue until no wrong is there. Now because of no wrong there, now what is the answer? Using some programming language implement. After implementation is over, now when I say run, program will goes to main memory running by the processor. So how much CPU time, how much main memory it is taking, that is called as analysis. These are the 6 steps. So if you follow these steps in this order, right? So for any problem, if you construct the algorithm in this using these steps, right, that will automatically follow properties of the algorithm. That will automatically follow definition of the algorithm. Please be careful. So until now 3 things I done to you. What is the first thing? Definition and example. Second thing, properties of algorithm. Third one, what are the steps required, right, to design algorithm. Totally 6 steps are there, right? And one more thing I want to ask you. In all these 6 steps, please give answer to me. In all these 6 steps, 6 steps you have to follow to design the algorithm, it's okay. In all these 6 steps, you only say which steps are complex. Right? In all these 6 steps, you only say which steps are complex, which steps are going to be related to computer science. In all these 6 steps, which steps are belongs to computer science? Let me say this one. Which steps are belongs to computer science is going to be, please be careful, right? Designing algorithm is very difficult. This is the only computer science people can do. Second step is really complex. Only CSE people can do. Some people are asking why only CSE people can do. What is the reason? They are the people who knows what algorithms are available, what algorithms are not available. CSE people, only people can do second step. Some people are asking what about first step? First step, I think, a problem definition, understanding the problem clearly. What is the meaning? You have to talk with the client. If you want to talk with the client, you should have good communication skills. I think first step is done by, right, some MBA people. Marketing people can do that. They will gather all the information. By talking with the client every time, they will gather the information. To understand the problem clearly, you should have good communication skills. Definitely programmer and the client cannot talk. Because programmer language is different, right? Client language is different, some problems will come, right? So better person to communicate with the client is going to be, right, MBA people, marketing people or management people, something like that. So programming and the client no relation at all, right? So I think a second step is CSE people can do that, right? Better way comparing with other people. So in all the 6 steps, major thing which is related to CSE people is going to be second step, design the algorithm. And one more step what CSE people can do, not other branch people, is going to be, right, analyzing algorithm. This also. Designing the algorithm, analyzing the algorithm, only CSE people can do, comparing with other people. They also can do little bit because they are not comfortable. So many basic concepts of the computer science. CSE people comfortable with all basics. They can cover second point, 6th point clearly. Other people also can do, they may not do that much efficiently. Now some people are asking, CSE people can do second point and 6th point, we are okay, but what about the 5th point? 5th point coding, mostly CSE people can do, right? Other branch people also can do. Right? The only thing is they have to learn the programming skills and all. But other things, right, other branch people, it is very difficult to learn second step and 6th step. But remaining step, other branch people also can do, CSE people also can do. But one thing, all the things can be done by the CSE people. I am really okay with that, right? But these 2 things are mainly CSE people only can do. Other things can be done, other branch people also, CSE people also. These are the major things. Can you say what are the major thing? Designing algorithm, and analyzing algorithm. Designing and analyzing algorithm. See this one? This subject name is designing and analyzing algorithm or analysis of algorithm and design. Next one, ADA also, algorithm design and different name, indirectly, directly same meaning. Can we help me one small line? In all the 6 steps, what are the steps will be done mostly by CSE people only? What are the answer? Second step and 6th step. Designing the algorithm and analyzing the algorithm. Based on those 2 names, right? They kept the subject name. Subject name is going to be DAA, design and analysis of algorithm. Next one more is going to be algorithm analysis and design. Next one is going to be algorithm design and analysis. Different, indirectly, directly, DAA, right? That is our actual subject. We are already seeing what are the steps required to design the algorithm, right? In all those steps, 2 important things mostly only CSE people can do is designing the algorithm, which is the second step, and analyzing the algorithm, right? Which may be the last step. These 2 are really important. Designing the algorithm and analyzing the algorithm, right? Designing the algorithm is nothing but we have to study designing techniques. So divide and conquer is the one designing technique. Greedy technique, dynamic programming, branch and bound, backtracking, so many designing techniques are there. Those we will study in further classes, right? Now let me concentrate analysis part. What are the 2 important areas we have to study as a CSE student? Designing the algorithm and analyzing the algorithm. Designing part we will see in further classes. Now let me concentrate on analysis, right? Let me write now. Let me concentrate on analysis, right? Now, what is the meaning of analysis? Analysis purpose is going to be finding time complexity of the program or algorithm, finding space complexity of the algorithm. To solve a problem, I written one algorithm. That algorithm while running will take how much time, how much space, we have to find it. That is called as analysis. Next one, some people are asking, sir, why are you finding first of all? What is the need? To solve a problem, there is an algorithm. That algorithm will take how much time, how much space. Why are you first of all finding, right? The reason is going to be, right? To solve a problem, I written algorithm A. To solve the same problem, my friend is written one more algorithm B, right? Let me write that one. See this one? To solve the problem P, I written one algorithm, name is A. To solve the same problem P, my friend is written one more algorithm B. So, to solve the problem P, we have 2 algorithms, A also, B also. Now, I am in dilemma, which algorithm I have to use to solve this problem, because to solve this problem, we have 2 algorithms. If only one, is it good one or bad one, I have to use it. But I have two, right? To solve the problem P, we have 2 algorithms, A algorithm and B algorithm. Right? So, the dilemma here is going to be which one I have to use, right? I think everyone now, which one I have to use, right? Which one I have to use, you cannot decide, I cannot decide. Who will decide? System will decide, right? Because you are running these 2 algorithms inside computer, whichever will take computer resources less so, that algorithm you have to use. I may like algorithm A, but system is saying that to me algorithm B better, then I have to use it. At the end of the day, you are running that algorithm inside computer. To computer, whichever is better, means whichever will take computer resources less so, that one we have to use it. Now I think it is the correct time to ask you, analysis purpose, finding time complexity, space complexity. First of all, why are you finding time complexity, space complexity? To solve a particular problem, we have 2 algorithms, right? In those 2 algorithms, right, which one is better? Just find the time complexity, space complexity for both, whichever is better for a system point of view. So that one we will use it. Now some people are asking, when the analysis part come into the picture, when it will come, right? If a problem having more than one solution, I am in dilemma, right? Which solution I have to use? What the analysis part saying is, first find for both the algorithm, time complexity, space complexity. whichever is better in terms of time and space, that one we have to use. Right? Supposing that this algorithm A taking, assume that n square time it is taking. This algorithm, if I give n inputs, this algorithm A taking n square time. This algorithm B taking n cube time. Then who is better? A better. The reason is it will take CPU time less. To solve the same problem, one is taking n square, one is taking n cube. If I give n value 10, assume it will take 10 cube time. It will take 10 square time. Right? I think whichever is less CPU time, that is a better. Right? So next one, some people are asking, this is n square, this is n cube, then n square is better, it's okay. Supposition that, right? This is not n cube, this is also n square. Then what is the answer? If time same, then go for space. If times are same, then go for space. Right? Suppose that it is taking space complexity. N inputs are given. Assume that it is taking space complexity. Assume that, right? It is taking n cube time. This is taking space complexity n square. Then it is better. If time same, then go for space. Right? I think a space point of view is better. Right? Please be careful. Time and space. And some people are asking, sir, whether I have to find out both or only one. First to find times. Because the time is really important. Right? I think nowadays space is not a big deal because within less cost only we can find, right? We can buy more space. Within less cost we are able to find out more space. If you buy a small, if you buy small cell phone of 1,000 rupees cost, right? In build there is a lot of space is available. Nowadays space is not that much big problem. Time is really important everywhere. First give importance to time. If time same, then go for space. Some people are asking me, right, sir, when I will go for space? But one thing is true, if we ask in the examination space, directly find space. If we ask directly time, then go for time. Right? Suppose if they ask you, who is better for space, then think about space only. If they ask who is better for time, then find out only time. If at all they will ask who is better, he didn't mention time or space. Simply is asking who is better. Right? So first give importance to time. If time same, then go for space. Right? Please be careful. Time they are asking, think about only time. Space they are asking, think about space. If they are not mention anything, simply which is better, first go for time, because time is more important than space, because nowadays space is not that much costly. Now can you help to solve the problem P? We have two algorithms A and B. A is taking n square, B is taking n square, both are same. Then go for space. I think by seeing the space is better. Overall B better. Some people are asking me, sir, this is taking n cube space. This is also taking n cube space. Then what is the answer? Time same, space also same. Then what is the indication? Right? Both the algorithms are similar power. You can use any one. The logic may be different, but both the logics are taking same size of computer resources. Right? So whenever both are taking same kind of resources, what is the best idea? You can go for whatever you want. Right? If times differ, then stop there. If times are same, then go for space. Space differ, then whichever is smaller, that is better. If space also same, both are same. Both are utilizing the same number of resources from the computer. So both are in the same power. You can use whatever you want. Now last time I want to ask you, analysis purpose. Finding time complexity, space complexity. Next one. When analysis will come into the picture, if a problem having more than one solution, which one is better will be decided by analysis. Based on two factors, time and space. Right? Please be careful. Now I am repeating again now. What is the current chapter going on? Analysis. Analysis purpose, finding time complexity, space complexity. Right, next one. When analysis will come into the picture, if a problem having more than one solution, which solution is better will be decided by analysis. Based on two factors, time and space. Right? Fine. I am thinking that you are really comfortable. Now see this one. Now I am writing. So our goal is how to find out time complexity, how to find out space complexity. That is our goal. See. Analysis, if you want to do time and space complexity, you have to find out. See, our goal now is going to be how to find out time complexity. Time complexity finding, space complexity finding. right? Analysis is based on these two factors, time complexity finding, space complexity finding. What is the meaning of time complexity finding? CPU time. To run this particular algorithm, how much CPU time you will take? What is the meaning of space complexity? Right? Main memory. How much main memory you will take? How much main memory you will take? How much CPU time you will take? That is called time complexity. How much main memory space you will take? That is called a space complexity. Based on these two things, analysis is going on. Right? Everyone know? Now let's concentrate. Right? Only time complexity. Now let's concentrate time complexity. How to find out time complexity? I am explaining this one. How to find time complexity. How to find time complexity. Right? That is our goal. How to find out time complexity. Please be careful. How to find out time complexity? Right? I am explaining now. It is really important. Please be careful. So I am writing now. See this one, how to find out time complexity, that is the topic name. Right, now see this one, I am writing. See this one, I am writing. Time complexity finding how? You only say. Time complexity finding how? I am writing now. Everyone know. As a computer science student, whatever I am going to teach, mostly everyone know. Right? But I will say systematically. Necessary things only I will cover. I don't go out of the syllabus, I don't go right lesser than the syllabus. I will cover necessary things all. And one more thing, necessary points which really important I will repeat again and again. So if you follow properly this class, right, it is more than enough. I used to cover 99%, right? Try to get everything. After my class over, if you felt that somewhere something else required, you can study. Little bit you can do from your side, but try to get as much as possible whatever I am teaching. Right? Fine. Now I am starting now. Time complexity finding how? I written this one. How to find time complexity. Right? This is a very important topic. Right? In this one, I think it will take a lot of time to complete this one. 20-30 problems I will cover. Most probably 20 problems I will cover. From now onwards you follow. In my opinion, algorithm subject just started now. Until now I given the introduction and all, right? So time complexity finding is the first topic, right, in algorithm subject. All the basics which are required, small things maybe I covered to you. Actual algorithm subject is started from here, right? Follow at least from now onwards, right? See this one, time complexity finding. Right, see this one, I think because of everyone fine now I am explaining. Time complexity finding now, see this one, see everyone now. Time complexity of algorithm A is equal to program A or algorithm A, whatever it is. Algorithm, program similar. Normal English line if you write, that is algorithm. Program means if you are using some programming language, if you write, that is called program. Both will be similar. See this one, algorithm A. See this one, time complexity of algorithm A. Algorithm, program same. Right? Algorithm is going to be English lines. Program is going to be right using some other language, maybe C, C++, whatever. Both will be similar. Please be careful. Now I am starting now. See this one. Time complexity of algorithm A. T of A is equal to, see everyone now. If you want to run any program, first you have to compile. See this one. Time complexity of algorithm A, T of A is equal to compile time of algorithm A plus running time of algorithm A. Time complexity of any algorithm T of A is equal to compile time of algorithm A plus running time of algorithm A. And one more. See this one. Compile. First you have to compile, then you have to run. Now see the answer. See everyone now. Compile time of algorithm A C of A plus running time of algorithm A R of A. Next one. You only say. Compile time of algorithm A is based on, right, compiler. Compile time of algorithm A is based on compiler. Next one, running time of algorithm A is based on, running is done by the processor. Means CPU. Compile time is based on compiler, running time is based on CPU. Next one more thing. Please be careful. Can you help me now? Compiler is a software or hardware? Compile time is based on compiler, running time is based on CPU, it's okay, that is okay. Can you help me now? Compiler is a software or hardware?
Compiler is a software or hardware? Everyone know. Compiler is a software. Compiler is a software means it is written, right, using some programming language. Suppose that everyone know. Compiler is nothing but set of rules. Compiler is nothing but set of rules. Those rules are written in some language. You can write, compiler means set of rules. Try to remember, compiler is not a language. Compiler is not a language. Compiler is nothing but set of rules. Those rules I can write in any programming language. I can write C compiler. I am repeating again. I can write C compiler in Java language. What is the meaning? C language rules I can write in Java language. Again I am asking you, compiler is a software or hardware? Software. What is the meaning? Right? Suppose in that C compiler, what do you mean? C language rules I written. C language rules I written in some language. I have some rules. I can write in any language. Whichever language I feel comfortable, in that language those rules I can implement. One more example I am giving, right? I have a number n. I want to check number n is a prime number or not. If you want to check n is a prime number or not, for that purpose you can write logic, right? Isn't that one logic is there? To check given number is a prime number or not, I have a one logic. That logic you can implement in any language. What is the language for checking given number is a prime number or not? Definitely this number n should have two factors, either one or that itself. To check given number n is a prime number or not, the logic is going to be, it should have only two factors, right? One and that itself. If at all more than two factors are there, it is not a prime number. This is the logic. This logic can be written in any language. So you cannot say that prime number program can be written only in C language, only in Java. You cannot say that. Logic can be implemented in any language in the similar way. I am created one language. That language having some rules. Those rules I will write in any language, right? Then I can say that that language compiler I written in some language. And once again I am asking you, C compiler is written in Java language. It is right or wrong? C compiler is written in Java language. It is right or wrong? Maybe right. What is there in that? What is the meaning of this one? C language rules I written in Java language. There is no problem. C language rules I can write in C language also. C language rules I can write in the C++ language also. C language rules I can write in the Node.js also. So I have some rules, I can implement that in using any language. Now I think because of you are really comfortable, right? Let me ask you one small line now. Please listen. Initially C compiler is written using some other language. What is the reason? Right? Because of the starting only, right? C compiler I am creating. So C language is not that much famous right that point of time. What the people done, C compiler they written, right? That the language which is famous that point of time, assume that C language is came that point of time, famous language, assume COBOL. So C compiler is written in COBOL language, or C compiler written in Pascal language. That point of time, whichever language is famous, in that language C compiler rules are written. So I can say that C compiler written in Java language. Now after few days, now C became famous and all. So C compiler they written in C language only. This is called as bootstrapping. What is the meaning of bootstrapping? Just use the other languages for the compiler of C purpose. Afterwards use C language for C compiler itself. Using initially someone else, afterwards using yourself, that is called as bootstrapping. If everyone know, if anyone don't know, please you take care. From today onwards, if anyone asks you, C compiler written in which language, what you say? In any language you can write. Whichever language is famous, whichever language is faster, that language. There is no emotional feeling here. C compiler should be written in C language only. There is no emotional feeling. Suppose that the people who invented the C language or Java language, if they felt that comparing our language, new languages are faster, Python is faster, assume that, right? So if they felt that Python is faster, they may write the C language compiler, C compiler in Python language. Right? You can write your own also, right? Comparing you something better there. Why don't use that language for the purpose of faster compiler? Now I think it's the correct time to ask you. Time complexity of algorithm A, T of A is equal to compile time plus running time. Compile time is based on compiler, running time is based on CPU, right? Please be careful. Next one, compile time is based on compiler, which is nothing but a software. Next one, when you say it is a software, this software written in which language? This software is written, compiler means software. This software written in which language? Suppose assume that some faster language you use, compile time becomes less. If you use some slow language, compile time becomes more. Right? Please be careful. Compile time is based on compiler, right? Compile time is based on a compiler, which is a software. Running time based on CPU, which is a hardware. Suppose this software is faster. This software is faster means what? This language. In which language this software is written? That language is faster. Then compile time becomes very less. Next one more thing, right? Running purpose CPU you are using, which is a hardware. Assume that this hardware is faster, then running time less. This hardware is slow, then running time is more, right? Please be careful. So, I think it's the correct time to ask you, compile time is based on what type of, right? Compile time is based on compiler, which is a software, means language of the compiler is really important. If the language of the compiler is, right, faster one, right, I think compile time is going to be less. Language of the compiler is slow one, right, I think it will take the more time. Next one, running time is based on the CPU, right, which is the hardware. So what type of hardware that matters? It is something like this one, right? So I think P3, P4, comparing P3, P4 is better, Pentium 3, Pentium 4. If you run the program in the P3 processor and P4 will be faster, P5 will be faster, something like that. Next one, i5, i7, i9, right, like that. Type of hardware matter. Running time is based on the CPU, which is the hardware. Type of hardware matter. So best CPU, I think a new model if you take, faster one, it may be costly, that is a different story and all, but one thing, type of hardware matter. Can you help me now? Compile time is based on a compiler, which is a software. So language of the compiler really matter. Language of compiler really matter. Language of compiler matters. So faster languages, compile time less. Slow language, compile time will be more. Language of compiler is important. Please be careful. Next one, type of hardware is important. Right? So this answer. Time complexity of algorithm based on these two things. Right? This is based on language of compiler. This is based on type of hardware. These two things are best to time complexity less. These two things are worst to time complexity more. These two are medium, then medium will be there. And one more thing I want to ask, these all are going on analysis chapter. Analysis is based on time complexity, space complexity. Right? Now we are finding how to find out time complexity, I am explaining. I am thinking that you are really comfortable until now. And one more, I can directly take the problems, I can explain also. But what is the problem? As a CSE student, it is your minimum responsibility to know what exactly algorithm subject, everything knowing clearly. If from now onwards, if anyone asks you, time complexity, please explain like this. If anyone asks you how to find what is the time complexity, please explain that. Explain like this. Whenever some interview is going on, they will ask you, please, do you know what is the meaning of time complexity? Can you explain? Right? Explain. Right? Don't explain in one line, two line. Right? Please eat as much time as possible. If you say in single line, they will also single line. Suppose that you know one problem answer very well, right? There is a problem, you know that problem answer very well, right? Don't say directly. If you say directly, right, I think actually it should be covered in 10 minutes. You took only 1 minute, right? Then the serious problem, what happened is, in the next minute you will ask some problem which is more difficult, which you don't know at all. Unnecessarily you are giving chance to him to reject. What is the best idea? Please take your own time. Prepare nicely, please give the answer. 10 minutes, give nice presentation. So, if you give 10 minutes nice presentation, you are giving correct answer, it's okay. Nice presentation you are giving. So, I think you can show your communication skills, your writing skills and your technical skills, everything you can show. Suppose assume that they asked something, you are given in 1 minute only correct answer. Then what they got to know? Right? I think you are technically strong. But they don't know your communication skills. They don't know your writing skills. If you want to show all your skills, right, take your own time, right, give some nice examples, right, write properly, talk properly, right, present all the technical skills, something like that. If anyone asks you from today onwards, please explain time complexity, explain clearly like this. right? I am thinking that this is the time complexity story. I think you are comfortable, right? Now see this one, time complexity of any algorithm based on language of compiler and type of hardware. If you are okay, whatever I said until now, now see this one. Now see, based on this entire story, whatever I discussed it till now, right? See this one, based on this, I am writing here. Listen everyone, analysis will be two types. Based on this, analysis will be two types, right? Whatever I discussed so far, based on that story, right? Try to please be careful, analysis will be two types, right? First one is going to be, right? First one is going to be, see this one, first one, posteriori analysis. A is silent. Posteriori analysis. Right, one more, priori analysis. Priori analysis, posteriori analysis and priori analysis. Right, now see the first point. Based on the story, whatever I discussed so far, analysis will be two types, posteriori analysis and priori analysis, right? What is the meaning of these two? I will explain now. Now see the first point. See the first point now. Now see this one. What is the meaning of posteriori analysis? What is the meaning of priori analysis? I will explain now. See this one. According to this analysis, let's see this one. According to this analysis, if I ask what is the time complexity of the program, suppose I have a program, I will ask what is the time complexity of this program. According to this analysis, what they will do is, if I ask what is the time complexity of the program, right, instead of giving time complexity of the program, what they will do is, they will ask you return back one question. What is that one? Right? What type of, right? What is the language of the compiler you are using? And next one, what is the type of the CPU you are using? They will ask. If I ask what is the time complexity of the program, instead of giving that program time complexity, they will postpone your question. What is the time complexity of the program is my question what I given. Instead of giving that, they will postpone, they will ask two things. What is the language of the compiler you are using? What is the type of hardware you are using? What is the reason? Without those two, I explained already. Language of the compiler, type of hardware. In which computer you are going to run this program? In that computer, right? Compiler is written in which language? And hardware is which type of hardware? Right? Without knowing those two, he cannot give answer. This analysis is clearly saying, that's the name itself saying posteriori. What is the meaning? He will postpone. I will ask what is the time complexity of my algorithm. Instead of giving that, he will postpone it and he will ask that what is the language of the compiler, what is the type of hardware they will ask. If you give those two things, then only he will give answer. So, this analysis is completely based on those two things. Let me write now. It is this analysis. It is means this analysis. It is dependent on. It is dependent on, right? It is dependent on this one, language of compiler. Language of compiler. It is dependent on language of compiler and type of hardware. Type of hardware. This analysis is based on name itself saying posteriori. What is the meaning? He will postpone. I am asking something, instead of giving that, he will postpone and he will ask two things. What is the language of the compiler? What is the type of hardware? It is dependent on language of compiler and type of hardware. If I ask the same question to my algorithm, what will be the time complexity? If I ask, see, name itself saying priori analysis. What is saying? Right? He don't postpone, he will give direct answer. So, it is independent on language of compiler and type of hardware. It is independent on language of compiler and type of hardware. Right? Next one. See this next one. See the second point, 2. Second point. Careful listen. So, this is the first fundamental property. Next one. Can you help me one small line now? Who is taking real things into consideration? First one or second one? If I want to say time complexity of the program correctly, definitely you should know what is the language of the compiler and type of hardware. So, if I ask this person, what is the time complexity of the algorithm? What he will say? Your algorithm time complexity based on right? In which computer you are running, right? That computer contain what type of compiler language and what type of hardware. Without those two, I cannot give answer. They are the real things which are required to find out time complexity. He will say, save those, then I will give answer. He will say, without those also I will give answer. Can you help, right? Who will give the approximate answer? Real things he is taking into consideration. He will give real answer. Real things you don't consider, I think he will give approximate answer. The advantage with this person is going to be, he will always give exact answer. He will give approximate answer. He will also give correct answer, there is no doubt. He will give approximately correct answer. He will give exact answer. So this is the advantage with this. He will give exact, he will give approximate. Right? Let me write now. So E, right? So I think E means what? Posterior analysis, right? It will give exact answer. It will give exact answer. 2. It will give approximate answer. It will give approximate answer. It will give exact answer. It will give approximate answer. Right. See the third step. Right. Now see this one. I think everything is fine now. Now can you help me one small line now? So which one is better until now? First approach or second one? He will give exact answer. He will give approximate. I think he is better. But one more interesting thing, he is also better. Some people are asking how, right? Some people are asking how. Let's see this one, right? If I ask this particular approach, what is the time complexity of this algorithm? I have a algorithm A. If I ask what is the time complexity of this algorithm according to this analysis, he will say this algorithm time complexity is 10 minutes in computer C1. This algorithm time complexity is 20 minutes in computer C2. This algorithm time complexity is going to be 30 minutes in computer C3. So he will keep on saying that different systems, different answer. Different system, different time complexity. If I ask what is the time complexity of my algorithm A, he will say in system C1, time complexity 10 minutes. System C2, time complexity 20 minutes. System C3, time complexity 30 minutes. System C4, time complexity 5 minutes. So system to system answer is keep on changing. But here, right, it is not based on the system. Right? That is the reason. So system to, in every system, same time complexity will take. Let me write now. Let me write that point also. Right? The drawback, I think it is the drawback here. The drawback with this approach is going to be computer to computer, time complexity will differ. Right? Let me write now. System to system. System to system means computer to computer. System to system, time complexity will change. Time complexity will change. System to system, time complexity will change. Right, see here, system to system time complexity will not change, right, same time complexity in every system, because anyhow it is approximate, same time complexity in every system, right. So it is because of it is a dependent, system to system time complexity will change, because of it is independent, see this one, because of it is independent. Because of it is independent, right? Same time complexity in every system. System to system, time complexity will change. Right? Please be careful. I hope everything is fine now. Now can you help me one small line now? So who is dependent? This person. Who is independent? This person. Because of it is independent, means actual things he is not taking into consideration. Say approximate answer. Actual things he is taking into consideration. Exact answer. Because of he is taking actual thing, exact answer, system changes, time also will change. System to system, different answer, right? In every system, same answer. What is the advantage here? In every system, same answer. Here, what is the drawback? System to system, different answer. And one more. So, who is relatively answer changing? First approach, second approach. Which is relatively answer changes. System changes, time complexity will change. But he is always same. He is always same. I think -5 + 5 same to him. But it relatively will change. This is also called as. So one name is going to be posterior analysis, another name is going to be relative analysis. One name is going to be priori analysis, this is also called as absolute analysis. Absolute means what? -5 + 5 becomes 5 only. Right? Let me write those names also. Let me write those names. So this is also called as what is the answer? Relative analysis. Relative analysis. This is going to be absolute analysis. It is going to be relative analysis, it is going to be absolute analysis. Right? I am thinking that it's okay. System to system answer changing, relatively answer changing, relative analysis, you don't change at all. So, absolute analysis. Now see this one, I think I explained already. See this one, based on this discussion. What is the discussion here? Time complexity based on language of compiler and type of hardware. Next one, some people are asking, these two things I don't know. Then also you can give answer. That is going to be priori analysis. These two things if you know, that is also okay. Posterior analysis. Right? One is independent analysis, another one is dependent analysis. Now how many people will give the answer at the correct time? At the one nice statement coming. Please listen carefully. This is a very, very important one. In the entire discussion, whatever I discussed so far, one nice line is coming. Please listen that. Please listen. Please listen this. See, I written one algorithm. One nice statement coming. As a CSE student is really important. Right? Please listen this. I have a one problem. To solve that problem, I written one algorithm. I have a problem. To solve that problem, I written one algorithm. Assume that algorithm is running so fast. There is a one problem. To solve that problem, I written one algorithm. That algorithm name is A. That algorithm is running so fast. I am feeling so happy that I written one nice algorithm. Right? So, but if I go to the first category, if I ask them, right, this algorithm running so faster, right, what will be the reason? If I ask the first analysis, what the first analysis will say is, right, your algorithm A running so faster, the reason is language of the compiler and type of hardware, right, in the system, right, compiler language whatever is there and type of hardware whatever is there, those two are the reason why your algorithm is running faster. I written one algorithm, that algorithm running so faster, right, so instead of giving credit to me, first analysis will say that credit will goes to type of hardware and language of the compiler. I thought that I am the reason because I am the person who written that algorithm. I am feeling so happy that I written one great algorithm. But first analysis is saying that the reason why your algorithm running faster is language of compiler and type of hardware. So, existing software and existing hardware is the reason, you are not the reason. That is the first analysis saying. But second analysis saying that your algorithm running faster, right? The reason for that one is not language of the compiler, is not type of hardware. It is the logic what the programmer written. So this analysis saying that programmer is the reason for that. If programmer is written the great logic, right, then program become faster. If programmer is written the worst logic, right, then program will take more time. This analysis saying that program running faster, programmer is the reason for that. This analysis saying that a program is running faster, type of hardware and language of the compiler is reason. So according to this analysis, programmer never get credit. According to this analysis, programmer will get credit. Now can you help total software industry follows which analysis? A program, I written algorithm A, that algorithm running so faster, right? Then what the software companies will do is, I written one great logic, my algorithm running so faster, then what most probably nice companies will do is, they will make me, right, employee of month award, or employee of the quarter award, or employee of the year award. Because of I done great performance, because of great logic I written, so they will recognize me by giving employee of year award, best developer award, best logic award, something like that. So all the software companies are following second model. Right? This is also okay, but this is not the reason for that. This is the major reason. Can you help These two things which is important, both required, both you have to take care about, both you have to take care. That is fine. But most importantly, great logics you write. Type of hardware and language of the compiler, they will also affect constant factor. They will affect the constant factor. right? Please be careful. And one more thing, let me say one small line. Let me give one nice example. Right? Please be careful. So, you know very well Google company and all, right? Before Google company came, there is a Microsoft. Before Google company, when Google company started, Microsoft is already number one. They are having lot of money. Before Google company came, right? Microsoft already there. It is the number one company in the entire world. They are having huge amount of money also, right? So they are having huge amount of money. They can buy supercomputer. They can do many wonders because they are having huge amount of money. But Google people are started just company, right? That time only. Microsoft already number one. So because of they are already having lot of money, they can buy supercomputer. If try to remember this one, if the program speed is completely based on type of software and type of hardware, right? Microsoft people could have constructed one nice search engine because they can buy supercomputer also, but Google people cannot buy supercomputer because that is just a startup. They don't have enough funds. But interesting thing is their brain is faster. They written the great logic. So search engine time complexity becomes very less. So try to remember your algorithm speed is completely based on, right, your brain. Your brain played great logic, your program become faster. So if you have a supercomputer, but inside a supercomputer you kept the worst logic, then even though supercomputer is there, no use. Right? Suppose that you have a very small computer, very slow speed, but great logic you written, then program become faster. Now last time I want to ask you, who will improve the performance? Both. Who will improve the performance? Both the things will improve the performance, right? But supposition that both the things you cannot, at least do this. Now can you help me one small line now? Which is practically possible? First one or second one? Which is practically possible? Everyone now. Practically possible is second one. What is the reason? Everyone is not rich. Everyone cannot buy supercomputer. Right? Everyone is not rich. You know very well. Only I think 5% people only rich people. 95% people is almost like, right, poor or maybe, right, middle kind of thing. So everyone cannot buy supercomputer. But one thing, everyone having brain. Every human, God is given for everyone same kind of brain. Some people will use it, some people don't use. So if you use brain and if you use the nice logic, that is more than enough. Suppose by God grace, right, you written the nice logic also, you have a faster computer also. If both the things are there, you are extraordinary. Both the things are not there, only one, this is possible, that is also more than enough. Google company people initially, they have only this model only. Let's write great logics, right? So I think because of they written the great logic, all the people are started using their particular search engine and all, right? Automatically they started getting huge amount of money. So now they are having combination. What is that one? They are having huge amount of money and they are having the nice brain also, great logics and supercomputer combined. I think mostly no one can beat Google people, because they are fundamentally following this, plus they are having funds also now. So from this entire thing, just I want to give one conclusion, just listen. Everyone cannot buy supercomputer, but everyone can write super algorithm. The reason is God is given same brain to everyone. The only problem is some people are using that brain, some people are not using it. Right? Please start using brain. You also can write the great logics. Some people are asking, sir, how to write the great logic? That's what we will see, right, in the further classes. Now I think before going to the next topic, I want to ask you one small line. Total software industry follows priori analysis only. So in GATE examination, one program is given. They are asking what will be the time complexity. Which analysis you will follow? Second one, priori analysis. This analysis saying that, right, type of the hardware required, right, language of the compiler required. That's okay, but that will affect only constant factor. But major things will be done by this only. Total software industry follows this model, right? In GATE exam also any program is given. They don't say type of hardware. They don't say language of compiler. Simply they will ask, one program is given, what is the time complexity? So you have to follow second analysis. But I hope you are okay now. Fine. right? Let's go second analysis, this only. From now onwards, if I ask you time complexity or if I ask you space complexity, you have to follow priori analysis only, right? Now I am writing now. See this one, priori analysis. Right? This is the next story. Right, priori analysis. Can you help me in the priori analysis? You only say, in the priori analysis, what is our goal? Our goal is the language of the compiler or language of the compiler, type of hardware. These two things are our goal? No, only logic. Priori analysis will take care about only logics, right? What is that logic? I will write now. What exactly priori analysis? How he will take care about only programmer logic, right? You will see now. I am writing also. What is the meaning of priori analysis? From now onwards, we will follow this only. Priori analysis. One more name is absolute analysis. What is the meaning of absolute analysis? Small things don't bother. Small things don't bother. That is the meaning of absolute analysis, which is also called as priori analysis. Right now I am writing what is the major logic behind this. How it will calculate only programmer logic. How it is. Let me write now. Right. Priori analysis is nothing but it is a determination of order of magnitude of a statement. Order of magnitude. It is a determination of order of magnitude of a statement. Right, this is the definition. Priori analysis is nothing but it is a determination of order of magnitude of a statement. What it means I will explain. Right. So from now onwards, please be careful. Until now I said so many theoretical things. Right. From now onwards, 20 programs will come. Those 20 programs, please don't by heart, get meaningfully. If you get these 20 problems meaningfully, afterwards any program is given. If you see the previous paper, if you see anywhere, right, mostly we can give answer. If you are unable to give answer, please check once again. Please check. If you do more practice, right, in GATE examination by seeing program, you will give answer. If you don't do practice before exam, in exam you have to do practice. Yeah, everyone will do practice, no doubt at all. Some people will do practice before exam, some people will do, right, in exam. Which one is better, you decide. More practice you do, right, in exam you will give answer. If you do more practice before exam, in exam by seeing problem you will give answer. Suppose if you don't practice in exam, some people will practice. This is the only difference. Now there is one more category there. Some people will do practice before exam, some people in exam, some people after exam. Those people who will practice after exam, they are buffaloes. If you are a nice human being, before exam, do practice as much as possible. If at all you are a worst human being, right, do practice in exam. Suppose in that you are a buffalo, right, do practice after exam. Please be careful. If your goal is GATE, before GATE exam, try as much as possible. See, I am teaching, I will try my level best so that every student will get my lecture. I will try my level best. You try your level best to get the good GATE rank. Don't do any complaints, right? Please take everywhere positive things only. Try to get as much as possible from my class. 1 or 2 small points are missing, ask your friends, right? So if possible, ask me, right? If at all, there is no possibility. Whatever books I said, one line you read from there, right? Worst case, see, other options will take a lot of time. If you listen properly in the class, suppose something is not clear, just once again revise, right? Just replay again, right? Something like that. Please make sure that, please utilize the available resources, then please grow as much as possible. Right? I am thinking that everything is fine now. So 20 problems will start from now onwards. Take care. Until now, one example also I didn't give in. How to find out time complexity. Right? Now I will give one by one problem. What is the meaning of this line? I will explain also. See the first problem. Time complexity finding using priori analysis. Time complexity means priori only. How it is? I written one statement also. I will explain now. Right? See the first problem. See the first problem I am writing. First example. Example 1. See the example 1. Main. X is equal to y plus z. Some program. Don't bother syntax and semantics. What is the meaning of finding time complexity? The logic whatever is there inside, that logic will take how much time we are taking care. We are not bothered semantic error. We are not bothered syntax error. We are not bothered lexical error. We bothered about how much time this program is taking. Whatever logic is there inside, that logic is taking how much time. That is the only goal. Right? So this is the program. How to find out time complexity? Let's see this. Let's see now what is the time complexity. Can you help me now? Can you help me now? In this program, how many statements is one? Program started, program ended. Can you see in this program how many statements are there? One statement. In this program, one statement there. Everyone now. Can you help me now? In this program, one statement is there. It's okay. While running, right? Whenever I will run this program, please this one. In this program, only one statement is there. I am okay. While running, this one. When I run this program, this statement will execute how many times? This program having one statement, I am okay. Whenever this program is running, the statement whichever is there, that statement will execute how many times? How many times? One time. Right? While running, this statement will execute one time. While running, a particular statement will execute how many times? How many times this statement? One time. This is called order of magnitude of that statement. This is called order of magnitude of that statement. This is one order of magnitude. While running, a statement will execute how many times? That is known as order of magnitude of that statement. Can you help me now? While running, this statement will execute how many times? One time only. No loop is there. So one time only it will execute. So order of magnitude of this statement is 1. Then see the next one. Then time complexity of this algorithm. Just keep capital O, big O, right? Big O of this one you write. Time complexity of this algorithm is going to be big O of 1. Just keep big O. Time complexity purpose. Normally people will use big O symbol. Sometimes omega also, sometimes theta also. Afterwards I will explain. As of now, not required. So time complexity of this algorithm is going to be big O of 1. Right? Big O of 1. Please be careful. Just find order of magnitude. Right? Time complexity of this algorithm is going to be big O of 1. Right? I hope you are okay. Right? If you want, you can write the omega also. Right? If you want, you can write omega. Afterwards, we will see. Don't worry about all these things. So, time complexity of this algorithm is going to be big O of 1. Right? That is the first example. Let's see the next problem. I think first problem fine. Let's see the second problem. See the next problem. Example 2. Main x is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus. X is equal to y plus z. Right? End of this particular program. Right? This is the program. Right? So this program time complexity how much we will see now. Right? Please make sure that, right, don't concentrate small thing. Whatever I am saying you listen. Lastly everything okay. Right? Whatever I am saying just follow blindly. Lastly mostly everything okay, because I cannot cover all the things at a time. Necessary points I will say, later I will cover small things also. Right? Whatever I am saying just follow it. Any doubt is there, remember those doubts. They will be mostly will cover in the next problem. Like the 20 problems are there. That is the reason. Right? So I am thinking that you are fine now. Let's see. This program time complexity how much? Now can I help you now? From today onwards you remember, if you want to find out time complexity, first step, find how many statements are there. Find how many statements. See this one. It is the one statement. Right? So see this one. It is the one statement. I am not asking how many lines there, I am asking how many statements there, right? This is the one statement, right? Now see this one, this is the one statement, it's okay. Now see this one, this is the second statement. This is the one statement, right? This is the second statement. This is the second statement. Now listen, some people are asking, then what about this for loop and all? Everyone know this loop purpose is repeating. This loop purpose is repeating. Now see this one, every I value he will execute. Every I value, each I value it will execute. I is equal to 1, he will execute. I is equal to 2, he will execute. I is equal to 3. So second statement is how many times that loop will take care. Can you help me now? In this program, how many statements are there? 2 statements. First statement and second statement. 2 statements are there. Can you help me now? First statement will execute. Whenever this program is running, first statement will execute how many times? 1 time. So first statement order of magnitude is 1. Whenever this program is running, how many times first statement is executing? How many times? 1 time. So order of magnitude of first statement is 1. Next one. Whenever second statement is executing, how many times he will execute? Let me check. See this one. How for loop is running, you know very well. See how it is running. In the for loop, see this one, how it is running. First to initialization. Next to condition checking, true. Then execute this statement. After statement is over, then increment. Right? Initialization, condition checking, true. Then statement will execute. Next incrementation. Next condition checking. Next statement. Next incrementation. Condition checking. It will continue. Now can you help me one small line now? Whenever this program is running, second statement will execute how many times? What is the answer? I is equal to 1. Right? 1 less than or equal to n. True. Execute. 2 less than or equal to n, true, execute. 3 less than or equal to n, true, execute. Continue. Lastly, n less than or equal to n, true, execute. Next one, it will become n plus 1. n plus 1 less than or equal to n, fail. Lastly, fail, come out. Okay, can you help now? For loop will execute. First to initialization. Next to condition checking, true. Then statement over, then increment, then condition checking. Then statement. I think this loop will keep on continue. Condition checking, statement, incrementation. Condition checking, statement, it will continue. I is equal to 1, 2, and so on, n time. N plus 1 fail. So n time this particular statement will execute. This program contains 2 statements. First statement order of magnitude is 1. Second statement order of magnitude is n. Here n, some people are thinking that here n statements are there. No. 2 statements are there. First statement order of magnitude is 1. Second statement order of magnitude is n. Now right now listen correctly now. So first statement order of magnitude is 1. Second statement order of magnitude is n. Can you help me now? Total order of magnitude. What is the answer? N plus 1. Now can you help me now? Total program order of magnitude is n plus 1. Okay. Now time complexity of this program is going to be, see this one, n plus 1, which is bigger. N plus 1, which is bigger, n bigger. So time complexity of this program, right? So actual answer is n plus 1. So time complexity of this program is approximately big O of n. Everyone know big O omega theta will be used for approximation. That is meaning of asymptotic notation. Afterwards you will see, you don't bother, right? So whichever is bigger, just write that one, big O of n. So time complexity of this program is going to be, first to find out how many statement. Next one, every statement order of magnitude you find out, right? Add all of them. This is going to be time complexity, right? To this one, right? In terms of big O notation, whichever is bigger you take, big O of n. Some people are asking, sir, actually n plus 1, how can you write n? That is the meaning of approximation. Small things don't bother. Small things you can neglect. If you want everything, right, then that is called posterior analysis. It will give you exact answer. Priori analysis will give approximate answer. Logics only you take care, right? So time complexity of this program is going to be n. Right? Fine. I'm thinking that you are absolutely fine. If anyone thinking that small doubts are there, sir, why not like this? Why not like this? After 20 problems are there, we will discuss about your doubts. Mostly 1 or 2 doubts will come. In every problem, 1 or 2 doubts will come, right? So definitely I will cover those also in further problems. Assume that first problem, second problem you are comfortable. Assume that. Small doubt there, keep in your brain. Don't forget also, right? At the end of the 20 problem, everything I will cover. Mostly I know what doubt you have, right? Fine. So I think second problem is completed. Time complexity of this program is going to be big O of n. See the third program. Right, let me write now. Example 3. Example 3. See this one, main. X is equal to y plus z for I is equal to 1,
I less than or equal to n, I plus plus, x is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus for j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. Right. So this is the third problem, example 3. So I think this is the right. So single for loop, this is the inner for loop. This is the inner for loop. See, for each I value j running, each I value j running, and so on. Here each I value, this statement will execute. Here each I value j running, for each j value statement is running. You know very well, this is the one program. It is the example 3. Example 3. Right. So two problems you are almost comfortable. Let's listen this also. I am really saying to you as a computer science student, right, algorithm you cannot escape. I am giving serious warning also. As a computer science student, you cannot escape from algorithm. The only way of escaping algorithm, right, please study carefully. Get everything. Right, that is the one warning I want to give to. Next one, in algorithm subject, everywhere which is really important in algorithm subject, finding time complexity. As a CSE student, right, you should know algorithm and you should know time complexity. As a CSE student, you don't know how to find out time complexity algorithm. It is the worst life ever. It is something like this one. There is an English teacher, right, that English teacher don't know grammar of English. There is no meaning in that. In the similar way, as a CSE student, in algorithm subject, you don't know time complexity. I can really say that it is the worst life. You are not done anything in 4 years BTech. That is the meaning of this one. At least now last chance is coming. Last chance. Please learn properly. Time complexity finding. Right. So first two problems I am thinking that you are almost okay. Right. Just listen this also. 20 problems are there. Please revise again and again. Right. So anything new please learn. Suppose that whatever I am teaching you know. Right. Well and good. So one new point also there. Right. Please take it. Everything whatever you know is well and good. Right. So because of your CSE person, I cannot say every time new things to you. Mostly you know. I am saying systematic order. Next one is in the proper order I am saying. I am not going out of boundary. I am not going below the boundary. There is some rule. Every game having some rules. Those rules and regulations you have to follow. Without following the rules, if you study whatever you want, finally you cannot be the winner. When you say GATE is a one goal, to that goal, there are some rules and regulations. Please read that only. After GATE exam is over, you study whatever you want, no objection. GATE you are preparing, GATE things only you read properly. Systematically, right, proper order I am saying to you. Mostly you know, any new point is there, you take care, old points it's fine. Right, fine. See this one, how to find out time complexity of this third program. See this. Right, now I am explaining. Can you help me now? Time complexity finding. Can you say first step? If I want to find out time complexity of this program, what is the first step? And one more, loops are there, loops are there. Don't count those as statements. Loop purpose, how many times you want to repeat? There is something I want to repeat many times, then loops will come. Right? So some other teacher may say some other way. Everyone is right in their own way. Finally, they all are saying same story. I am saying my way, some other one is saying some other way. At the end, everyone will convey the same meaning. So I know how to make sure that every student will get what actually going on. Right? So finally, everything all right. Please be careful. Right? Can you help me now? From now onwards, if I say find time complexity, first step. Find time complexity, first step is going to be find how many statements are there. Let me find out. Loops don't count. Right? Remaining things count. Can you help me? How many statements are there? Let me check here. Let me check this one. It is the first statement. Right? I think it is the second statement. It is the third statement. It is the third statement. So this program contains 3 statements. First one, second one, third one. Can you help me now? Whenever this program is running, first statement will execute how many times? One time.
whenever this program is running, because of lack of loop, one time we will execute. Now you only say, whenever this program is running, second statement will execute how many times? Every I value, this will execute. Each I value, this will execute. How many times? N time. Next one, can you help me now? Right? Third statement will execute how many times? Let me check this one. I value 1. 1 less than or equal to n. I value 1, 1 less than or equal to n. This condition true. If this condition true, every true, you have to execute statement. I think everyone now. To this is the statement. To this is a statement. For us, it is a statement. To this person, right? These are statement. For this person, these are statement. Right? For us, this is the only statement. Please be careful. Let's start now. Let's start. Meaning wise, all are okay. Don't worry. Don't worry. Loops don't give numbers. Remaining things give numbers. Now, can you help me now? I value 1. 1 less than or equal to n condition true. Then execute this. J is equal to 1. J less than or equal to condition true. Execute. Then afterwards increment. Then right, it will continue. Can you help me one small line? How many times it will continue? Let's check here. What is the answer? I is equal to 1. J. 1 will execute, 2 will execute, 3 will execute, and so on, n. Right? J value incrementing. Whenever J value becomes n plus 1 less than or equal to n fail, then what is the answer? Then I plus plus. This is fail, then I plus plus. Then I value becomes 2. Now, whenever this is incremented, I value becomes 2 less than or equal to n condition true, then come here. Then what is the answer? Same. J is equal to 1, J less than or equal to 2, and so on, n. Now, whenever this is failed, then I plus plus. What is the answer? I value 3, then J is equal to 1, 2, and so on, n. Like that, it will continue. Can I say what is the last one? It will continue like this one. Lastly, I is equal to n, J is equal to 1, 2, 3, and so on, n. So, like that, it will continue. Can you help me one small line now? Right, third statement will execute how many times? What is the answer? Each I value n. Each I value n. Like that, n times n. What is the answer? N squared. Second statement will execute n square time. Can I say first statement 1, second statement n, third statement n square. Inner loops. Inner loops means what? Each I value j will execute. Right? Each I value j will execute. Can you say what are the loops? One after another. After I over, j will start. What is the meaning of inner loop? Right? Each I value j will run. Each I value j is running. That is called inner loops. After I all over, then j will start. They are going to be outer loops. See this one. After these all i's over, then this I will start. They are outer loops. Every I value, j value running, they are inner loops. Right? I am thinking that first statement order of magnitude is 1, second statement order of magnitude is n, third statement order of magnitude is n square, then total order of magnitude n square plus n plus 1. Right? So, in all of them, which is the bigger one? N square, big O of n square. Whichever is bigger, you take. Right? Time complexity of this program is going to be big O of n square. Right? I am thinking that you are fine. So, 3 programs, time complexity find out, you done. Now, can you help by seeing all these 3 programs? By seeing all these 3 programs. If you want, I will minimize also. Say this. Three programs you done. So, by seeing these 3 programs, time complexity, can you help by seeing all? What is the time complexity? Let me check this one. Can you help Can you help So, you will find out order of magnitude of every person, right? Every statement order of magnitude you find out, you add them, whichever is larger, that is the time complexity, you know very well, right? I think by seeing this one, people got to know. What is the answer? Time complexity finding is nothing but. Time complexity finding is nothing but. Actually, you have to take all, but in that you are taking bigger only. Some people are asking, sir, why are you taking bigger only? Time complexity finding is nothing but not finding the total time. Time complexity finding is nothing but because of approximation you are following. Time complexity finding is nothing but not finding all, right? Time complexity is nothing but finding the place where CPU is spending more time. I am repeating once again if anyone having confusion. Time complexity means normally finding every person, right? Everyone know, that is okay, right? So, one more better way of saying time complexity is nothing but, right? So, even though many are there, bigger one you are taking, which is nothing but time complexity finding is nothing but the place where CPU is spending more time. You know very well where CPU spend more time normally in loops. Now, can you help from today onwards if anyone asks you, what is the meaning of finding time complexity? Finding time complexity is nothing but finding the place where CPU is spending more time, which is nothing but finding loops. because loop is the place where CPU spend lot of time. Now some students are asking one more interesting line. Sir, no loop is there. No loop is there. What is the time complexity? Constant. See. No loop is there. Time complexity constant. No loop is there. Every statement is constant, right? 1, 1, 1, 1, 1. Order of 1 is nothing but a constant time complexity. From today onwards, you remember. Big O of 1. Another way of reading. Order of 1. Big O of 1, order of 1, both are same, which is also called as constant time complexity. Now can you help now? Time complexity finding means finding loops. Time complexity finding means the place where CPU is spending more time, which is nothing but finding loops only. If no loop is there, what is the time complexity? Big O of 1, which is nothing but constant time complexity. Big O of 1, order of 1, constant time complexity, all are same. Next one. Can you help see the second program? Second program, what is the meaning of time complexity? Finding loops only. Let me check. From now onward, time complexity you have to find like this one. First statement, find the statements how many? 2. Right? After finding how many statements are there? 2 there. Next one, ask the first person, are you loop? No. Second one, ask, are you loop? Yes. Loop is how many time? N time. Time complexity n. Time complexity finding is nothing but finding loops only. Ask every person, are you loop or not? No. Leave it. No. Leave it. Loop. Then count it. Next one, some people are asking, time complexity finding is loops, we are okay, right? No loop is there, constant time complexity, it's okay. One loop is there, that is the time complexity, that is also okay. If more than one loop is there, what is the answer? If more than one loop is there, in all those loops, whichever is the larger, take that. Can you help in this program, right? How many statements are there? 3 statements. Let's see this one. First statement, are you loop? No. Second statement, are you loop? Yes. How many time? N time. Third statement, are you loop? Yes. How many time? N square. So which is the bigger? N square. So time complexity of this program is N square. So time complexity is nothing but finding loops only. If no loop, time complexity constant. If one loop, time complexity that only. If many loop, larger loop is the time complexity. From now onward, no need to waste your time and my time also. Time complexity means finding larger loop. If one loop, that only. No loop, constant. If many loops, larger loop. Right? I'm thinking you are almost okay. Right? I'm thinking you are almost okay. Now see the next one. One more interesting line. Right? See the next one now. So maybe this doubt may be there. I want to cover that also. Right? See this one. 3 examples are over. I want to cover this also. Many students are having this doubt. I want to say starting only. Some confusion will come. That is the reason I postponed. Right? Now I am saying now. Listen. Now I am saying. Make sure that you listen this. Right. See this. Now can you help me one small line? See this one. Each I value j will rotate n time. Each I value j will rotate n time. Like that n times n square. Right? You are okay. Now see the answer. Each I value j will rotate n time. That's okay. Supposing that j is equal to 1, j less than or equal to n. It is not n. It is n by 2. Assume. J is equal to 1, j less than or equal to n by 2, j plus plus. What is the meaning? Each I value j is n by 2. 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 If you are okay with that, then what is the answer? N times n by 2, which is nothing but n square by 2, which is nothing but n square by 2 plus n plus 1. Now can anyone help me now? N square by 2 plus n plus 1. You only say which one is the larger one. Time complexity means larger one only. Which is the larger one? N square by 2 is larger. Which is nothing but, listen, which is nothing but 1 by 2 into n square. Which is nothing but big O of n square. Constants you can neglect. It is a constant you can neglect. N square by 2 is actual answer, right? Which can be written as 1 by 2 into n square. 1 by 2 is a constant, neglect. So answer is big O of n square. Larger loop only answer. Constants are there, neglect. Some students are playing some jokes also. What is that? Constant I have to neglect. Sir, this is a constant you neglected. Sir, this is also constant. Why don't you neglect? Everyone now. N square is not a, that 2 is not a constant. Right? It is going to be n into n. It is looking shortcut. It is looking like n square. Right? N power 2. But 2 is not 2 here. N into n. N into n. Right? So this is a constant. Right? N square. It means n into n. The meaning of this one is n into n. You know very well. So constants you can neglect. Now some people are asking, sir, why are you neglecting constant? You know very well. See this one. Even though it is a function, small function I neglected. Small functions you can neglect. Constants also you can neglect. It is a constant neglect. It is a small function. Bigger one you take. In the bigger one, some constants are there like this, you can neglect. Right? Please you take care. Now can you help me one small line now? Suppose assume that each I value n by 2. Assume that this is also n by 2. Then what is the answer? This is also n by 2. Then what is the answer? N by 2 into n by 2, which is nothing but n square by 2 square. Finally, plus n plus 1. Finally, what is the answer? N square by 2 square. Finally, 1 by 2 square into n square. Finally, big O of n square. So constants you can neglect. Don't think that much about constant. I am thinking you are almost okay. Right? You are almost okay. Now let's come here. Let's come here. See, some small confusion is there. I want to clarify that also. Please see this. Please see. See this one also. Interesting answer is coming. Maybe your doubt is like this. Now some students are asking. See this one. So first statement is one time only executing. I am okay. Second statement is executing. See this one. Second statement is executing n time. That is also okay. But some people are saying that second statement is executing n time, that is okay, but whenever this statement is executing, this also executing, this also executing, this also executing. Right? Can you help me one small, let's see this one. When you want to execute this one, let's see this one. This is true. This is right. This one assignment. Next one is condition checking. Then this. Afterward this one. Afterward this one, and so on. Can you help me one small line now? We are counting this as the statement. It's okay. But one thing. This is also a statement. This is also a statement. This is also a statement. So everything is a statement. This is the keyword is okay. This keyword internally contain this also statement, this also statement, this also, this also. Can you help me now? Right? This statement will execute how many times? N time. This statement one time only. This statement n time. Last one fail. Actually it is n plus 1. This one n time. So I think this one if you observe 1 plus plus 2 plus plus 3 plus plus n plus plus also totally n time. This also n time. This is 1 time. This is going to be n plus 1, right? If you add all of them, let's see this one. If you add all of them, first statement order of magnitude 1, right? First statement order of magnitude is 1. Can you say what is the second statement? This will execute n time. This is also this is n plus 1. This is n time. This is 1 time. Let me add all of them, right? Let me add all of them. This is 1 time. This is n plus 1 time. This is n time. This is n time. Total how much? 1, right? What is the total one? I think it is going to be 3n plus 1, 2, 3, which will goes to, can you help me now? 3n plus 3, right? Which is the bigger 3n, which is nothing but 3 into n, which is nothing but big O n. Meaning is same. Meaning is same. Right? Some people are thinking that, sorry, here actually 3n statements are there. Isn't that approximately n approximate? Here 3n, how can you say n? Right? That is the meaning of approximation. Right? Small things you don't bother. Simply, right? First statement, how many times executing? Right? 1 time. Second statement executing how many times? N time. Here n is there, 3n is there, 4n is there, doesn't matter. Second statement is executing n time. There may be so many participants inside. Right? Totally 3n, which is nothing but n only. First statement order of magnitude 1. Second statement order of magnitude 3n. If you want to say clearly 3n plus 3. 3n plus 3. Right? Bigger one n. That is the reason. At the end n only. We are doing approximation. Priori analysis means approximations we are doing. Small things don't bother. Simply for loop don't count them. Right? Whenever I say how many statements are there, for loop don't give number. It is the 1, it is the 2. First statement order of magnitude 1. Second statement order of magnitude is n. Actually 3n. 3n plus 3 if you want. Right? Actually 3n. So even though 3n, just make it as n because, right, approximately 3n and n same here. Constants you are neglecting. That is the reason. So this is second statement is n time. Totally n plus 1. Right? Time complex is big O of n. In the similar way, can you come here now? First statement order of magnitude is 1. Second statement order of magnitude is n. Actually how much? It may be 3n. So this is n time, this is n time, this is n. Plus or minus 1, don't bother. n, 3n, but I written n. Because anyhow, we will take bigger one only. I think constants I can neglect, same way here. This is going to be, some people are asking here, see this one. This is n time, right? This is n, this is n. If you observe clearly, what is the answer? Each I value, listen, each I value. right? Each I value, what is the answer? I think this will execute, I think this is going to be 3n, this is going to be 3n into 3n, something like that, which may be 9n square, but we will take n square only. Constants neglect. Constant don't have that much value, don't think that much. That is the reason simply, right? So here one loop, n time, here two inner loops are there, n square, 1 plus n square, which will become n square. I want to say starting itself, you may be confused, that is the reason I didn't cover. For loop is there, just concentrate only one thing. What is there inside loop? Don't bother. Loop is how many time? Loop is how many time? Inside loop, what is there? Don't think that much. If really necessary, then go inside. Not necessary. Loop is how many time? What is the meaning of order of magnitude? How many times you are executing that statement? Right? I think here, right? One time. Here, what is the answer? So this is, I think that is okay. Right? Let's go to the, right? Next problem. See the example 4. I'm thinking that almost you are okay. Let's go to the example 4. Example 4. See, most probably you are okay. These 3 problems, whatever I said until now, if you listen properly, mostly you are okay. Right? From now onwards, new things you can learn. Right? So, how many times that matters? Constants you can neglect. Sometimes really necessary, you have to calculate those also. Right? Until unless they will press you, right? Really not required. Simply see loop is how many time. If they want really, they will ask you, please count inside, then you can count. Right? See the example 4. Main. While I less than or equal to n, I is equal to I plus 1. While I less than or equal to n, I is equal to I plus 1, x is equal to y plus z. While I less than or equal to n, I is equal to I plus 1, x is equal to y plus z. Now see this one, I is equal to 1. This is the program. This program time complex to how much? We will see now. Right? This is an example for this program time complex to how much? We will see now. And one more. Right? Syntax errors, semantic errors, don't bother. Time complex to how much? We have to calculate. And one more. When you say how many statements are there, right? Don't count the loops and all. Right? Can you help me now? How many statements are there in this program? How many statements are there in this program? It is the one statement. That is okay. Right? I think this area, second statement. You may say that, sir, inside 2 statements are there. Don't bother inside what is there. Simply how many statements are there? How many? I think see this one. This is the one statement, this is the second statement. It is the first statement, this is the second statement. Here may be 2 there. If you want, you can say 2n. First to find out how many times. If you want, you can multiply. Inside 2 people are there. You can multiply by 2. If you want to say, sir, this also executing, you can multiply by 3. What is there in that? First to count how many times. Our goal is here how many times. Now, can you help me one small, time complexity finding. What is the answer? How many statements you find out, that is okay. And one more thing, you find out all the statement order of magnitude also, but time complexity means loops only. If many loop, right, larger loop you find out. Right? Time complexity means from now onwards you concentrate only loops. Other things also you can concentrate, it is wastage of time. And one more, inside loop, count everyone. No need to waste your time by counting all. Simply loop is how many time. Time complex means finding loops. Inside loop what is there? How many statements are there? No need to concentrate that much. Loop is how many time? Now I will concentrate. Loop is how many time? Can you help me? How many statement? 2 statement. Is first statement is a loop? No, leave it. Second statement is a loop. Yes, loop is there. Second statement is a loop. Now can you help me now? This loop is how many time? Let me check. Inside what is there? You don't bother. This loop is how many time? That matters. Let's check here. This loop is how many time? This one I is equal to 1. So 1 less than or equal to n. Do this work. Afterwards I plus plus. Next one. 2 less than or equal to n. I plus plus. 3 less than or equal to n. I plus. I think this loop will execute n time. You know very well, right? Until previous problem, I written the for loop. Now I written while loop, right? Both are similar. So each I value, condition checking, do this. Condition checking, do this. Condition checking, do this, and so on. Can you help me? This loop is how many time? What is the answer? N time. So time complexity of this program, because of this loop is n time complexity is n. If you want to see every time this is executing, this is executing, this is if you want you can write 3n. 3n is nothing but big O of n only. Now write it. Time complexity of this program is big O of n. This loop is n time complexity is n. If you want to count these also, it will become 3n, right? This may become 3n. This also 3n, which is nothing but big O of n. That is the reason. Don't bother how many are there inside, simply count how many times. Time complexity means how many time, right? I think you got the fourth example also. This problem, previous problem difference. Previously there is a for loop, now here while loop is there. Now you really find now time complexity means loops only, right? In that loop also don't count everything, just simply see loop is how many time, loop is how many time, that matters. If anyone asks you inside exactly I want, then count 3n. Every time you are executing 3 people, 3n, right? That is the reason. Fine, you are okay now? See the next one. This is example 4. See the example 5, interesting one. See the example 5, very interesting point is coming. Example 5, see this. Main. I is equal to 1. While I less than or equal to n. I is equal to 1, I less than or equal to n. Now see the answer. I is equal to I plus 2, x is equal to y plus z. Main, I is equal to 1, I less than or equal to n, I is equal to I plus 2, x is equal to y plus z. Now can you help me one small n now, right? Time complexity means what? Finding loops only. Just directly go to the loops, don't waste your time and my time also. Time complexity means finding loops only. Directly go to loop. I think this is the loop. This is the loop. Forget about this one. Loops only go. Yes, I went here. Inside how many people also there? Don't bother, right? So time complexity means finding loops. Yes, I came. This loop is how many time? I will try now. This loop is how many time? Can you help me now? Initially I value 1. Can you say after I value 1, right? Condition true, you will go. Next one. I is always, in the previous problem if you observe, I is always incrementing plus 1, plus 1, plus 1, plus 1. Now here always I is incrementing plus 2, plus 2, plus 2. Can you help me now? Always plus 2. How many times? Assume that I want to reach 100. Assume that I want to reach 100. From 1 onwards I started. Then what is the answer? 1, 2, 3, 4. If I go always plus 1, plus 1, plus 1. I want to reach 100. Always I am incrementing plus 1, plus 1, plus 1. 100 times. Suppose assume that I want to reach 100. Always plus 2, plus 2, plus 2, plus 2, plus 2. What is the answer? Write 50 times. If you always write plus 2, plus 2, plus 2, I think within half time you will reach. So previous problem if you observe, always plus 1. Now here always plus 2. Now this one. I want to earn 100 rupees. But every time I am earning 2 rupees, 2 rupees, 2 rupees. I think 50 times. 50 days I have to do. Every time I am earning 2 rupees. But I want to reach 100 rupee, total I think 50 times. So, can you help me now? Time complexity of this program means loops only, this loop. Can you help me now? This loop is repeating how many times? What is the answer? Every time plus 2, plus 2, plus 2, plus 2. What is the answer? N by 2. Please be careful. Every time plus 1, plus 1, plus 1. What is the answer? N by 1. If you always plus 1, plus 1, plus 1, N by 1. If you always plus 2, plus 2, plus 2, N by 2. 100 by 2, 50. If you want, you can check. And one more, some people are asking me, sir, if it is an even number, odd number, don't think that much about even number, odd number, because both differ by minus 1, plus 1. What is there in that? See, n by 2 itself, I will write n only, because 1 by 2 is a constant, right? N by 2 itself, I am writing n, right? N by 2 minus 1, n by 2 plus 1, really doesn't matter. Correct place, think. Unnecessary place, don't think. Correct place, think. Really required, think. Even number, odd number. Really not required. Because that is the meaning of approximately. That is the meaning of priori analysis. Priori analysis doing the great work. What is that? Unnecessarily, please don't think. That's what the right priori analysis is saying. Small thing, minus 1, plus 1. If you keep on wasting time, minus 1, plus 1. Right? Big functions you are eliminating. Big constants you are eliminating. What is there minus 1? What is there plus 1? Right? Please be careful. Can you help me now? This loop is executing how many times? N by 2. Because every time plus 2, plus 2, plus 2, n by 2, which can be written as 1 by 2 into n, which is nothing but big O of n. Now some students are asking one interesting line. See this problem. Some students are asking some interesting line. Sir, always plus 2 plus 2 plus 2 n by 2 you are saying means big O of n. Suppose isn't that always plus 12. Always plus 12. If you want you can check. If at all always plus 12, this is going to be n by 12. If you want you can verify. Which is nothing but 1 by 12 into n, which is nothing but big O of n. Right? Fine. Now some students are asking me always plus 120. Then what is the answer? N by 120. You verify yourself. N by 120 and one more. When you are verifying minus 1 plus 1, don't bother. Small differences, don't bother. That is the meaning of right approximate analysis. That is the meaning of priori analysis. Which is nothing but 1 by 120 into n. Finally, which will becomes big O of n. Right. You are really comfortable with this problem. See the next problem also. Almost you will learn this one. Those people who are comfortable until now, right, almost half of the time complexity finding you got. The major things are pending, that's okay, but basics you are strong, right? Whenever you are constructing house, right, basement construction is over, means almost house over. Without basement, what will you do? Base is important. If you are really okay with the base, right, further story becomes very simple. Right, I am thinking that you are okay. Let's see the next problem. So what is the previous one? Example 5. Now see the answer. Example 6. Right, example 6. See this? Main. I is equal to 1. While. Interesting one. This also will bring the new point. I less than or equal to n. Make sure that this is a very interesting point. I is equal to 1, I less than or equal to n. Now see the answer. I is equal to I plus 2. I is equal to I plus 2. That is fine. I is equal to I plus 2. That is fine. Now see the answer. Interesting one. Please make sure that in every problem some difference there. I can complete all the 20 problem. In one problem only I can write all. I can explain, but I have to take care about every incident, every point. That is the reason problem wise I am saying. In every problem something new there. If you want you can check. Now see the answer. This example 6. Example 6. Please see once. Can you say time complexity finding? What is the answer? Loops only. Please go to the loop. Time complexity findings, finding loops only. Yes, it is a loop. This loop is how many time? This loop is how many time? What is the answer? I think every time 2 incrementing. Every time 2 incrementing. If you increment always plus 2 plus 2 plus 2. What is the answer? N by 2. That's what the previous problem. Always plus 2 plus 2 plus 2. I think n by 2. You know very well. Suppose always plus 20 plus 20 plus 20. N by 20. That is also okay. But see the interesting story. Always plus 2 n by 2. Always plus 20 n by 20. That is also okay. Suppose if I write like this. If I write one more line. I is equal to I plus 5. What is the answer? One time you are adding 2. One time you are adding 5. Total how much you are adding? Total you are adding, this is equal to, I is equal to I plus 7, which will goes to, what is the answer? N by 7, which will goes to big O of n. So, first plus 2, afterwards plus 5. They can write directly plus 7, but they didn't return. To confuse you, they will write plus 2 first 2, next plus 5, totally plus 7. Which will goes to, right, I is equal to I plus 7, which is equal to n by 7, which is nothing but big O of n. Some people are asking one small line, sir, I is equal to I plus 2, I is equal to I plus 5. Suppose if I write here, I is equal to I plus 8. What is the answer? Plus 2 plus 5 plus 8. What is the answer? 7 plus 8, I think 15. Total, if you observe, this is equal to, what is the answer? I is equal to I plus 15, which is equal to n by 15, which is equal to 1 by 15 into n, which is equal to big O of n. This is the answer. Time complexity is nothing but loops only. In that is also, that loop is how many time? That loop is how many time? It is completely based on, right, how I is incrementing. So, in the previous problem, if you see, I is incrementing only plus 2, I is incrementing only plus 5, I is incrementing only plus 20, like that. But here, all incrementation, instead of writing one time, they written multiple times. Right, multiple times. To confuse you only, they will give. It is really not a complex one, easy one like previous. But he written, right, he written many times. He written many times, but meaning if you observe, I is equal to I plus, whenever I do one round, I is incrementing by 15. In the previous problem, if I do one round, I is incrementing only plus 2, only plus 5. But here, I is incrementing overall in one round by 15. Right? I am thinking you almost got. This is, I think, if you are okay with that, this is also one of the nice point in time complexity finding. Right? Let's go to the example 6 over. Let's go to the example 7. One more new point will come. Example 7. Main. Example 7, main. See this one? I is equal to n. Some people are asking, sir, how can you write that directly I is equal to n? Because of I is already big. N means big number. I is already big. If I is already big, what will happen? Let me check here. Right? I is equal to n. See the answer. While I, because of I is already big. Right? See this one. I. Already I is big. Please take care. Right? I is greater than or equal to 1. I is greater than or equal to 1. Can you help me? I is already big. If I is already big, how can you repeat the loop? What is the answer? It is already big. I will keep on decrease. Until 1 will come. Can you help me? What is the I value initially? N. That n may be 1 lakh. See this one? 1 lakh greater than or equal to 1. Yes. What is the inside? I is equal to I minus 1. I is equal to I minus 1. I is decrementing. What is there in that? In the previous problem, I is incrementing. Start from small. If you want, you can check. See this one. Start from small, then increment. Until now, what I done is, right? Previous one, see that problem, this problem, both are loops only. Loop purpose is going many times. If you want to go many times, start from small, increment. If you want, you can check the previous problem also. See this problem also. Start from small, increment. Before that also, all the problems what we done so far, start from small increment. See, start from small increment. Now one more round is coming. What is that one? Start from big. See this one, start from big. See this problem? Start from big, then decrement. That is also loop, this is also loop. Loop purpose is repeating many times. Start from big, then decrement. Can you help me now? I started from the n. I am decrementing. How you are decrementing? Always minus 1, minus 1, minus 1, minus 1. If you always, it is something like this one. I have 100 rupees. See this one. I have 100 rupees, right? I have 100 rupees. Always I am, right? Every day I am spending, I have 100 rupees. Every day I am spending 1 rupee. I have 100 rupees. Every day I am spending 1 rupee, 1 rupee, 1 rupee. You only say, after how many days I will become bhikari? I have 100 rupees. Every day I am spending 1 rupee, 1 rupee, 1 rupee. After how many days I will become bhikari means after how many days I will get 0? After 100 days, every day 1 rupee. 100 days over. 100 rupees are out, then I will get 0. Every day 1 rupee I am spending, I have 100 rupees. It will take 100 days. Same thing. What is the answer? This loop will repeat. What is the answer? N time. N by 1, which is nothing but big O of n. That is the answer. So this problem, previous problem, same. Previous problem, start from small and increment plus 1 like that. But here, start from big, decrement minus 1 like that. Both are similar. That is the incrementing loop. This is the decrementing loop, but both are loops only. Here, no one interested. Incrementing loop, decrementing loop. Simple question. Loop how many times? Sir, it is an incrementing loop. Sir, it is a decrementing loop. I am not interested in incrementing, decrementing. I am interested. Loop how many times? So here loop is how many time? N time. Now see the one more interesting line. Every time 1 decrementing, n by 1. If at all every time 10 decrementing, then what is the answer? If at all this is the case, n by 10. Same thing like previous. 1 by 10 into n. Finally, big O of n. Right, see the one more interesting answer. See this one more interesting answer. I is equal to I minus 10. This is the answer. Suppose that I is equal to I minus 10. One more line. I is equal to I minus 5. Only this is there, n by 10, only this is there, n by 5, these two combinedly there. What is the answer? This means I is equal to I minus 15. This is equal to, right, n by 15. This is equal to 1 by 15 into n. 15 into n, which will goes to big O of n. This problem, previous problem same. Previous problem all are plus. This problem all are minus. Can you help now for the plus? What is the reverse minus? Their increment, here decrement. Both will be similar meaning. The only thing is different ways of asking. There also loop, here also loop. Right? So there loop is going how many times? Here also loop is going those many times. There start from small increment. Here start from big decrement. Right? This problem and previous problem almost similar. Different way of asking. For the plus, what is the reverse minus? For the minus, what is the reverse plus? What is the reason? So 10 minus 5. 10 minus 5, 5. Right? 5 plus 5, 10. Right? If I subtract, I got some number. If I add back, same number I will get. So these two are reverse to each other. If you know plus, you know minus also. Right? So I think example 7 also completed.